In this next video, we are going to see how can we start Apache Flink project, an application, empty application from scratch. As I already said in the first video, in order to develop an application as complex as this one, we must include some outside dependencies in our code. And in order to include those dependencies and build the project, including the dependencies itself, we must use a build automation tool. For example, Maven or Gradle or SBT if we want to develop our code in Scala. In our case, as we already said, we are developing the projects in this course. We will be developing them in the Java programming languages. So therefore, when using Java, you can use both Maven or Gradle, but Maven is more dedicated to Java written applications. So that's why we are going to use that. Over here, you have a command that you can run in a terminal, and this command will create an empty a project in Apache Flink framework. So this is the exact command that we are going to run. First, before running that, we have to make sure that we have Maven installed. Over here, I already have it installed, so there are no issues with that. So let's run this command. Let's see what are we going to get. So first, it will download a bunch of stuff for us that's needed, and then it should interactively ask for details about how do we want to name our application. This can maybe take a while. Okay, now it's going to start, or no. Yeah, now it's going to start. So first, when we are developing a Java-based application, we have to an application that is going to produce the Maven artifact, like the jar files. We should define a value for the group ID. The group ID is usually the website of the company where you're working. So, for example, I'm part of the Faculty of Computer Science in Skopje. So the value for the property group ID will be the web domain of my faculty, but in reverse order. So maka.ukim, that's the name of the university, .finki. The artifact ID will be, for example, mock course. Let's name it that way. And the version will stay this one that's default, or let's maybe do it 1.0. Package will be that one. And we just have to confirm that everything is okay. So we press yes. And the build has been completely done. So now if I do ls-l over here, I will see mock course created. So let's open this project with IntelliJ that serves as an integrated development environment for Java. So when we are opening the course, we will see that there is over here in the folder there is a pom XML file. This pom XML file is the most crucial file when we are working with Maven build automation tool. This is where all of the details on how the software should be built is written in it. So we can open the whole folder like this, or we can open the pom XML file. This will we will click open as project. This can take a while just to resolve all of the dependencies that are written in the pom XML file. So let's go through the content of that file while we are here. So by default, this quick start has generated a source folder over here. In the source folder, we have main, and then we have Java. And after we have Java over here, as you can see, we have packages just like we have defined the group ID. So Maka, Ukim, Finki, just like we have defined them. And this is a normal Java practice when you're developing projects in Java. So over here we have two jobs that have been okay. So we have two jobs over here that are like we are going to delete these two. We won't need them, but they have been generated. There is one batch job and one streaming job. Of course, We are going to use our own code over here, so we will definitely delete this. Just it will take a while to download all of the Maven plugins. So let's go through the POM.xml file over here. The POM.xml file will give some details about the application that you're going to define over here. So as we already defined the group ID, the artifact ID, the version, the packaging type, this should be packaged into a jar file, which later we are going to submit into our Flink cluster. We can definitely change the name of this application. Let's name it something like this. Over here, we have some global variables declared in the properties. So we have the Flink version. This is the latest version, 1.14.4. The target Java version, 1.8. The Scala binary version. This is needed because most of the Flink source code is written in the Scala programming language. We have the Maven compiler source and target. They are the same as the Java version, in our case 1.8. Um, Regarding the repositories, we won't be explaining this much. And here comes the one of the most important part. This is the dependency. So our code is dependent on other things like the source code of Apache Flink. So we don't want to download the source code of Apache Flink framework all the time. We just want to include it as an external dependency. And this is how we do it in the tag dependencies. We list all of the dependency that we need. So one of them is actually the Apache Flink Java artifact is the one of them. This is actually just another YAR file like those that we are going to create in this course. Then we have the Flink streaming Java because we are going to need that for all of the tasks with data streaming. And then we have a Flink client which will be needed. Over here, for example, we have some other dependencies that we might include later. One of them is a dependency for a connector to Kafka. The next one is log4j. This uses in order to create logs over here. And yeah, we have some other plugins. One is the Maven compiler plugin. This is enabling us to run some of those stuff over here. Actually, we changed the name, so we should re-import everything. Just press on this button. Um, yep, and that's pretty much it over here. This is important thing as well. We define the main class as you previously saw in the previous video. When we are starting a job on the cluster, we have to specify the main class. We will probably change this one over here. We don't want it to be a streaming job. This is a predefined job that we are going to delete. And yep, all of this other stuff is auto generated and not much needed. Here it comes now. The name of the application has been changed. So regarding Maven, Maven has several life cycles. One of the most important is definitely the install one or the package one. So what does this do is actually it's going to install the whole project, and it will create a jar file for us. The jar file will be created somewhere here in the target directory. And this is actually the jar file that we are going to drag and drop into the Flink cluster in order to start the job running on the cluster. Also, we can test our applications in Apache Flink locally using the IDE, and we are going to show an example of that. So let's write our first application. I'm going to write it here in this package. Uh, let's name it first example. Here it is. So all of Java applications, they have to be written. The execution logic has to be set into a public static void method. When working with Flink applications, there are several steps in the anatomy of one Flink application that must be taken into account. The first one is we must create a stream execution environment. You can see that, for example, here from the streaming job, here it is, it's created as well. We might even copy it, so we don't type it environment. Here it is. I would just delete this final. It's not necessary. The second step over here, it would be to create a data stream from some source. The third step would be, I will just name the steps over here and then we can go one by one over here. The third step would be to do something with the data stream. So we can do some processing, we will call over here. So we will call over here, call some of the Flink operators that we are going to learn in the next videos. At the end, actually it's not at the end, this is the fourth step. The results from step 3 should be sent to a sink, a data sink. This data sink can be just a regular data sink like the screen. So it can be just a print method. That's just a regular sink. And at the end, this is a mandatory step. We must call the execute method to run this application. So env.execute, and over here we can give a name to the to the job, and this is how the job will be displayed under this name in the Flink cluster UI that we have seen in the previous video. I usually go with this convention, so the name of the class.class.getName, and it will be named first example. This of course has it's, let's say, dangerous. It can throw an exception, so make sure to surround it with try and catch. This can be automatically done in IntelliJ, or maybe add exception to the main method, but this will cause your application to fail. In both cases it is going to fail, so it doesn't make a lot of sense. So let's see how can we create our first data stream. Our first data stream is going to be some strings randomly generated. We'll decide on that, but how do you create actually a data stream? You create it from the stream execution environment. So let's create a data stream. This is a generic object, so we have to put over here what kind of objects are going to be in the data stream. Let's say they're going to be strings. Let's import data stream over here. Okay, input data stream. Let's name the variable like that. So env, and we are going to go from source over here. Give me a second to see what was the exact definition of this method. Actually, no. Read file, we can read a file, we can add source. Yeah, this is the one that I was looking. So we can add source, and add source over here expects a source function. So I'm going to define a source function now. So I will create a package over here, sources, and in the sources I will create a new Java class that will be named random string, or first example data source. Name it like this. This class, as we see over here, should be a subclass of the source function of string. So let's go there and write extends source function of string. There it is. As it is an abstract class, the source function is an abstract class. We should actually, it's an interface, so it should be implements, and we should implement the methods. The methods are over here. The most important method is the run method. This cancel method, we can do nothing over there. We don't have to do anything. But this run method is actually a method that we're going to use in the next exercises, and in this one, in order to generate a stream of data. We will see how can we use actually a stream of data, for example, some sources like Kafka, etc., if we have time in the course. But this is how you can generate some test data streams. So let's say that we are going to, let's say, I don't know, maybe send 1000 data samples. So start from 1, go to 1000 maybe. This means that we will have a bounded data stream. This data stream will have its end. It will finish eventually. It won't be an unbounded data stream. Let's say that we're going to have a message. The message is going to have, for the sake of this exercise, just an ID. The ID will be the value of I. And let's say we want to get the timestamp. So let's create the timestamp of the current moment, local date timestamp. equals to local date time dot now. So we're going to get the current timestamp while we're running the application. Let's create the message. The message will be in the following format. So let's, for the purpose of this message, let's make it something like, I don't know, ID. It would be something of a structured data. So the ID and timestamp. The timestamp would be a string, or the timestamp object of type local date time. We will get its string notation. And how do we generate that data stream? Well, in the source context over here, we call the method collect. Actually, we can even call the collect with timestamp. This will automatically assign a timestamp to our data. So we already have the timestamp. We can call it, or let's do it without it. Let's do it without it. Collect. So it will just collect all of the messages. But as I said, we want to simulate a stream. So if we do it this way, it will just shoot 1,000 messages right away. So let's make this method sleep for several minutes all the time. So let's have a random object as an instance variable of this class, and this random, let's say it will define how much time should it sleep. So the sleep expects a long. So let's say random. Let's do it with next long. I don't know if we have a bound. Yeah, we have a bound. So let's do it with maximum of 2000 milliseconds. That would be like oh, actually, hold on. It's next int. Okay, and we might need to, no, let's put 1.5 second over here. So this is how we have defined the source. The source is the class first example data source. And now over here, I'm going to create an object of that class with the new operator. There it is. I have to import it because it's from a different package. It's from the package sources, import class. Here is the import statement. Okay. Okay. Let's say, for example, what do we want to do for the moment being? We won't do anything related to the third step over here, but for the fourth step, we definitely want to print the results. So let's call the input data stream dot print. This is how you send the data stream to the most simple data sync that exists, and that data sync is the screen itself. So it will get over here. So let's give it a try to run this, and of course probably it won't succeed from first time. Let's take a look. Yes, this is a usual error that you can get when running your Apache Flink application for the first time. What you have to do is go here and press Edit Configuration, and let me see if I can find it. Modify options. We need to press a variable that says include provided scope. Just give me a second to find that. This is a new version of IntelliJ, so I'm not quite yet familiar with all of it. Local machine, manage targets seem okay. Nope. So in order for this to work, we have to specify first thing we must make sure of several things. The first thing is that we're using Java 11 or Java 8, but not just here in the POM XML file for the Maven. We should also check in the preferences that we have the according JDK. We can check that. We can check here in file project structure. Here I have a JDK 11 installed, so I select that as the SDK here in the project. And then one of the most important things, if you want to test your code in IntelliJ, is you have to go here to edit configurations. For the edit configuration, you must include this part over here. That was why it wasn't working before. How do you do that? You go to modify options and you check over here this add dependencies with provided scope to class path. So now we can run this first example that we have defined. First we'll get a bunch of logs and then the printing will actually come over here. So at the moment I have double printing. Let me just delete that. So we just have the input data stream dot print. I was testing some other stuff. Let's run it again. Here they are. So as you can see, the output starts to coming out to the screen. We have the IDs and the timestamps, the exact timestamps when the data was generated. What's the meaning of this over here? This is the meaning on which core. For example, over here I have 16 cores on my computer on my local machine. On which core the data sample was processed, and this of course will take for a while, all until all of those 1000 data samples are printed. So what can we do in order to how can we make this? I will stop the program now. We can use the install command in Maven as already said in order to generate the source version project settings. Okay, project settings, modules, libraries, artifacts. Open project settings. Yep, it's all good over here. Invalid target release. Okay, let's go to the POM XML over here. It says that let's maybe make it like this and see if this works. Okay, let's try now. Okay, looks good. Yeah.